In this presentation, we'll continue to talk about light, but we will talk specifically about reflection and a smooth versus a rough surface when it comes to reflection of all electromagnetic waves, not just light. So we mentioned this before when we talked about sound, but the law of reflection is valid regardless of whether the surface is smooth or rough, has bumps, is something like mirrored, regardless of what the surface is like, the law of reflection is still valid, meaning that the angle of incidence is equal to the angle of reflection. We consider diffuse reflection to occur when you have light that's coming in or a wave. So I keep saying light, but this really represents any type of wave. So when waves come in, and I'm going to focus, let's say, on electromagnetic waves. So when electromagnetic waves come in, and they all come in parallel, so this bunch here, you can see coming in, are all coming in parallel and hitting this surface. Now this surface appears to have bumps in it, and so as I look at the rays of light coming in, here's one ray of light coming in and it reflects off, the law of reflection is still valid because I would have to draw a normal to that surface where it hits, and my normal for this particular surface would point somewhere over here. When I go to the next one, the law of reflection is still valid. My normal to the surface would be somewhere over here. And let's just go somewhere over here. So I've got a ray of light coming in and reflecting off. The normal to this surface would be someplace over here. And so essentially this surface appears to be bumpy because as I look at the different points of contact, the normal to the surface would be in different directions, and therefore the light reflects off in different directions. And so, but the law of reflection is still valid. So this is considered diffuse reflection because as the rays come in, they don't all reflect off in the same direction. They sort of reflect off in different directions. Specular reflection, essentially the surface is extremely smooth and the light so we're talking about light, but again, this could be any electromagnetic wave, comes in, hits the surface, and because that surface is very smooth, all of those normals to the surface are essentially parallel, and so the rays of light will reflect off parallel to one another. So a good example of this is if you had a flashlight, a really narrow beamed flashlight, and you were shining, it's dark outside, and you're outside, and then you have a mirror somewhere. When you hit that mirror with the flashlight, if someone is standing at the right location, they're actually going to see a really bright light at their eyes, where someone else who's not standing in the right place is not going to see that reflected light hit them as well at all. So diffuse reflection, the rays of light sort of go all over the place. Specular reflection, they reflect off because that surface is very smooth. And so with this diffuse reflection, the eye could actually see it at both locations. So we can ask, how do we determine whether a surface is smooth, meaning that you have this specular reflection, or if it's rough, meaning it's more diffuse reflection? So it turns out that when we're talking about electromagnetic waves, the smoothness of a surface depends on the wavelength of the light that's being reflected off of the surface. The longer the wavelength of light, the smoother the surface appears. So that's kind of a weird statement. And again, when I say light here, I really mean any type of electromagnetic wave. So the longer the wavelength of the electromagnetic wave, the smoother the surface will actually appear upon reflection. So visible light has very, very small wavelengths. So most surfaces do not appear to be smooth. So you get this diffuse reflection. So if you shine light on a wall, you don't, if you take a flashlight in a dark room and you shine it against a wall, the light just kind of spreads out all over the place. But in general, if you shine it on like a mirrored surface, it would be considered more smooth. So how do we determine whether the surface is going to be smooth or it's going to be considered rough? So the way that we do that is we look at the wavelength of the light, or the wavelength of the electromagnetic wave, and if the wavelength, the size of the actual wave, is large compared to imperfections in the surface, then the surface is considered to be smooth. So if you have a very large wavelength and you have a very small imperfections in the surface, then essentially when that wave hits that surface, you're going to have specular reflection, and it's going to be smooth. If the wavelengths are very tiny compared to imperfections in the surface, then that surface is going to be rough. So radio waves have very long wavelengths, and thus surfaces appear smooth to radio waves. Lots of surfaces appear smooth to radio waves. If you have radio waves coming in parallel to one another, they will reflect off, basically going in the same direction because those wavelengths are so small. So here's a quick question, and this is something that is often asked on exams or on homeworks and things like that. So suppose that I have a surface that's considered smooth for visible light. We want to know what other types of electromagnetic waves would also consider that surface to be smooth. So here's visible light, and we know that visible light makes up a very small portion of the electromagnetic spectrum. And here's the wavelength range, right, from 400 to 700 nanometers, right in here, of the visible light. So a surface will be considered smooth if it has a large wavelength compared to the imperfections in the surface. So light is already smooth, right, for this particular surface. So anything that has a larger wavelength would also see this surface as being smooth. So in terms of our picture, if I go down my picture, that's larger wavelength. So what other types of electromagnetic waves would see this surface as being smooth? Anything below. Infrared, microwaves, radio waves, TV rays, all of these would also consider that surface smooth. We could consider what other types of electromagnetic waves might consider the surface rough. So we have to say might because it depends on what that surface is, but essentially anything that has a smaller wavelength might see that surface as being rough, meaning if I go up here with smaller wavelengths, ultraviolet, X-rays, and gamma rays would all see this surface as being, or could see this surface as being rough. And so essentially you could ask this question for anything on here. I could say a surface is considered smooth for microwaves. So here's microwaves. What other surface would consider the surface, what other electromagnetic waves would consider the surface smooth? Anything that has a larger wavelength in microwaves, so anything below here, right? Radio waves. And the surfaces, and what other electromagnetic waves would consider the surface might consider it rough? Anything above, right? Infrared, visible light, ultraviolet, X-rays, anything above microwaves in terms of smaller wavelengths.